again, thank you for joining this month's series for SOLIDWORKS electrical products, and that's going to include today SOLIDWORKS PCB overview. Next week, we're going to have a SOLIDWORKS electrical overview and design. And then in the last week of the month, we will do a collaborative effort using SOLIDWORKS models, electrical, and the circuit board that we're going to view today. We'll see that in a collaborative model, and we'll make some edits. Today's format is going to be a short presentation about the new product, SOLIDWORKS PCB and SOLIDWORKS PCB Connector. We're going to look at the tool itself, look a little bit at the library functionality, the schematic functionality, the circuit board layout functionality, and then we will collaborate that design file into SOLIDWORKS and show you the editing capabilities that you now have inside of SOLIDWORKS using real circuit board design data. I'm the product manager here at Hawk Ridge Systems for SOLIDWORKS PCB. It's a brand new product. It's been out about 9 months. It is powered by Altium technology. So under the hood, the engine is the same with some new wrappers. So joining the SOLIDWORKS ecosystem under the electrical products, we now have the full discrete electrical design solution along with electronic design solution, which is now including full schematic capture, full circuit board design capability, along with real-time collaboration inside of SOLIDWORKS through a database. So typically in the past, most companies have used file import-export to transfer ECAD and MCAD data back and forth, whether it's IGES, DXF, number of different methods, all of which are not real-time and do require file import and file export. Some of the challenges in that process, right? We have duplicate effort. Mechanical engineer draws the outline. Circuit board designers got to redraw the outline in some instances, got to place the components at the recommendation of the mechanical designer. Those functionalities are completely eliminated with the SOLIDWORKS collaboration that's contained inside SOLIDWORKS PCB and the connector for Altium Designer. Our tools are push-pull with history tracking and the ability to do real-time edits both from the PCB circuit board design side and the mechanical 3D environments. So we do have two products. First product is the full SOLIDWORKS PCB application powered by Altium, includes the connection to SOLIDWORKS so that you can collaborate your designs back and forth directly. The second product is exclusively for Altium Designer, and that is the connector product, which allows the exact same collaboration that I'm going to demonstrate today, just allows Altium Designer users to collaborate with SOLIDWORKS. No other CAD tools in today's environment have this level of collaborative integration. This allows for a much smarter, innovative, connected product from the very beginning because you are sharing data directly back and forth with your mechanical engineers. SOLIDWORKS PCB contains the full schematic capture tool, like I mentioned. This is just a quick snapshot of the environment. We will be taking a look at this in depth during the software demonstration. Full PC board layout capabilities as well, including all bills of materials, all manufacturing outputs, everything required to manufacture and assemble printed circuit boards, including 3D visualization mode inside of SOLIDWORKS PCB, allowing you to attach models to your footprints, view those models, move the models, and look at the entire PC board represented in a 3D mode. The collaboration with SOLIDWORKS is really the differentiator with these tools. Like I mentioned, we have a database behind the scenes, and we're looking to push-pull data back and forth. We have a couple other methods of SOLIDWORKS integration from a model perspective. We can still export step files, we can still export BRMLs and step. The design rule capabilities in SOLIDWORKS PCB is completely flexible to allow you to design the boards that best fit your manufacturer's capabilities. You have all of the clearance rules, all placement rules, all routing rules. Everything can be completely set up to ensure that you have a fully manufacturable PCB. Within the schematic, we can attach to distributors and suppliers and provide you real-time links to the components that you have in your design. I'll demonstrate this in the schematic where we will look at a connector and we will see its data sheet, we will see the quantity pricing and the availability of that component. That's very helpful when you're selecting new components or looking to replace maybe obsolete components or components that are no longer available. The user interface of SOLIDWORKS PCB is inspired by SOLIDWORKS. It's extremely easy to learn, to understand. It's tab-driven, ribbon-driven approach. The icons are very self-explanatory. Again, we'll take a look at that in the tool. This is a close-up of the collaboration panel. So this is the panel that attaches to the database behind the scenes where the data is pushed and pulled back and forth between SOLIDWORKS and SOLIDWORKS PCB. So that's an overview of the product itself. Let's get into the software and take a look at what we're looking at. So this is the schematic that we're going to be working with this month from the circuit board perspective. We have designed a consumer product, and we'll get more into the details of the exact product next week and the week after. But essentially, we've come up with a specification that our product needs to have, some connectors, some functionality, and I've gone off and designed the schematic and the circuit board that we'll use in the product. This is just a pretty simple 2-page schematic, not extremely complex by any means. I've also went ahead and created some new library components for this project, and here in the footprint editor is where we can see visualization of the 3D model. So this is the true representation of our 8-pin Molex MiniFit Junior, and this will be represented in SOLIDWORKS when we collaborate the board. This is important because this is also going to be associated with the electrical portion of our project. So Charles Mayu, our electrical product manager, him and I have gotten together and we've selected particular connectors for particular reasons that best fit both of our libraries, both of our ability to complete the design in a manufacturable method. The schematic library, again, each symbol editor is fully functional for multi-block symbols. Multiple footprints can be associated to schematic symbols, as well as hierarchical schematics from these symbols. Because this is Altium technology, we can read Altium library files directly, and we've already compiled multiple gigabytes of libraries that we can provide to our customers to get them started in the very beginning of using a new tool, or in parallel if they already have existing Altium Designer. I mentioned the supplier links. We're going to look at this particular component. It just happens to be a dip switch. It is in our design, and like I mentioned, here's our data sheet, here's our quantity, the price of the quantity when you purchase in those amounts, and just by simply clicking on the data sheet, we're going to get the PDF from the supplier of that exact data sheet. And that's very handy because engineers can spend a tremendous amount of time searching for components, locating components, where in this instance, when you create a component, you can search the database that comes with the software and look at the availability of the components. If you have a database extract from your PLM system, you can create a standalone file, and SOLIDWORKS PCB can point to that file to link up with those components. You don't have to use everything that's on the intranet. That's basically the library editor for the footprints, the library editor for the schematic symbols. I've got fairly small libraries here, but if I go to View Library Panel, I've got multiple libraries set up in my system, including manufacturers' libraries like TI Logic, Micron Memory, Freescale microcontrollers. All of these were downloaded directly from the internet and most contain the 3D models, which is important when doing collaboration to SOLIDWORKS. Let's go take a look at our main design here. So again, I mentioned the functionality of the tool being quite simple. It's project driven, so the schematic capture documents and the PCB documents are contained within the project within the single application. So in those instances where you have multiple engineers, some companies have individuals that do just exclusive circuit design, schematic capture. Others are dedicated exclusively to doing circuit board layout. These tools can pass files back and forth very, very easily. Each tab has a ribbon associated with it, and in both instances, both for the PCB and for the schematic, you find most of the commonly used commands on the Home tab. The View tabs allow for what you'd expect: zoom in, zoom out, center, look at your different messages. You can customize your layout. We have a link to the automatic help. This is online documentation from SOLIDWORKS, and within this documentation there is a tremendous amount of tutorial information, tremendous amount of video information. So customers find this quite helpful when trying to just understand one particular aspect of the software in a higher level fashion. I mentioned it's project driven. So within each project you can have custom templates. Our project options tab is the same between the PCB and the schematic, and what this allows you to do is to customize your electrical rules verification. So here you can set up all of your rules from your schematic perspective to make sure that all your power pins are connected properly, you're not driving, output pins from an input source and things like that. And you can trigger whether or not just to get a warning or actually have the compiler stop for particular fatal errors. The tool does multi-channel design. So if you have a 16-channel audio amplifier, you just have to draw one channel and create a hierarchical block for that channel, and then tell it how many channels you want. And when you edit the first channel, it automatically will edit the remaining 15 channels of your 16-channel amplifier. Outputs from the schematic, pretty typical: prints, bombs. Let's go to generate outputs. You can create all of the output generation both for the PCB and for the schematic in one simple dialog box, or you can select individual ones by checking the associated selection. So for fab and assembly, that's related to the circuit board. Documentation is both the PCB and schematic. And of course, the bill of materials is always driven from your schematic. I've mentioned the connector that we looked at in the library. This is our speaker connector, the 8-pin Molex. I'm going to show you that supplier link as well. And again, direct link to, in this particular case, it's DigiKey, and we've got all the information for that particular component. So as I build my libraries, the first thing I do is always attach a supplier link, because it will be tracked every time you instantiate that component onto a schematic, or you can create your symbols individually and then add the additional supplier links at the schematic level. It's completely up to the user. Also want to show you the capability that SOLIDWORKS PCB has to read other CAD files. So we have a tremendous amount of other tools available on the market, and we included importers for those tools such that if customers do decide maybe a migration to a more collaborative mechanical tool is a good fit, rest assured, in most cases, we can acquire and we can bring your legacy libraries and your legacy data forward. I think that's a big advantage when customers are looking for an enhanced migration to pick up additional value in a CAD tool. You want to make sure you do have a roadmap and the capability to retain your legacy data. The tools that are available in the schematic capture, these are sort of the higher level tools where you do your annotation. You can have full pin swapping capabilities. You can configure logic gates. You can configure resistor packs. You can configure any component that you wish to have pin swappability. And then in the PCB, you can automatically pin swap it, or you can selectively pin swap it to have a better route configuration. The SPICE simulation that we provide is an XSPICE output, and you attach the models to your symbols, and you can generate the XSPICE simulation files. And then this is the same outputs that we looked at previously. It's just available in another location. So again, our schematic today, it has 2 pages. They're linked together. Everything's already been associated. I've customized a number of things in this project, including the wire size, wire color, onboard, offboard, on-page, off-page connectors to ensure the nets cross between the 2 pages, customized links, customized images. The tool is very, very flexible. All right, let's move to the PCB. So this is the completed and routed PCB. Similar to what we looked at in the library. I'll give you a quick snapshot of the 3D visualization. So now we get all of our models, get all the placement, and this is going to be very similar to what we're going to expect to see when we do actual data push to SOLIDWORKS. I can place components in the 3D mode within SOLIDWORKS PCB. It has that functionality as well. So let's take a look at the PCB tools. Again, pretty straightforward. Everything's tab driven, everything's ribbon driven, but the icons very self-explanatory. This design has a lot of the functionality built into it. I've done a lot of copper pour. I've automatically set my thermal ties for my vias and for my components. I can set the clearance. But let's start in the beginning. Layer stack up, right? Every circuit board's got to have a layer stack up. The very nice thing about this tool is SOLIDWORKS will read the thickness based on the parameters that you put into your layer stack up. So we have a total thickness of 61.6 mils. That's pretty typical. SOLIDWORKS will recreate the PCB and it'll give it the dimension thickness of 61.6. So that's very beneficial when we're checking for connector height in openings, clearances, mechanical interferences. We're rest assured we have a true representation of our PCB. Tool contains the design rules that we looked at in the presentation. This is the real time. So I've set these up for pretty standard manufacturing, including silk screens, solder masks, hole size information, minimum, maximum, acute angle, so that you don't get acid traps in your board, placements, silk to board edge, many net antennas. Make sure you don't get stubs out there radiating energy into other circuits. Connectivity, power plane connectivity. You can do direct connects. We can do thermal ties. The tool is extremely powerful and can produce most all of today's current technologies, including HDI, high-density interconnect with microvias, sequential lamination boards, not a problem, control impedance boards, no problem, differential pairs, high-speed boards. SOLIDWORKS PCB has that entire functionality to create those kinds of PCBs. We have full copper port capability like I've demonstrated and used in this design. Dimensioning is quite easy. You have the selection to do multiple types of dimensioning depending on what your company standards may be. You can do design rule checks real time. You can do design rule checks individually. What else we got? Route. In interactive route, we're doing one route at a time. Differential pair route, we're picking up 2 routes at a time where our differential pairs would be set by the schematic. And in the interactive multi-routing mode, we could select an entire bus and route that with just highlighting each individual pin. I'm not doing a lot of functionality and actually design time today because I want to provide you more of a high-level overview of the tool and not necessarily just dig in and do certain kinds of functionality. What we will be doing in a series of YouTube videos and blogs is we will be digging into smaller aspects of the functionality. We'll do certain topics on how to start projects and how to create schematic symbols and a little bit more detail to provide customers some focused information. The View tab is the same as the schematic. We have a nice feature in this tool. You don't see this very often in CAD tools at all. We actually can flip the board and design it from the back side. So if you have components on the back, the whole design is automatically mirrored, so you can more easily align your text and your reference designators will be properly reading left to right. Layer visibility window in this tool is, again, very easy to understand, very easy to adjust and customize to each user's preference. Full colors, full layer visibility on and off. The layers that you don't need don't have to be turned on. You can selectively turn off all of the copper if we like and just look at the placement. There's the placement of our board, no copper. Copper back on. So the library panel is the same as the schematics. So you can drag and drop components right onto the PCB. You can actually design on the fly with this tool. You don't have to have a schematic. You can drop components and you can start routing. You just need to tell the tool to ignore short circuits because you're not driving it from a schematic. But that's another real advantage because a lot of CAD tools have to be driven from a net list, and SOLIDWORKS PCB does not. Projects, this is again where we would add new documents. We can add multiple schematics. You can add multiple PCBs to the project. The generate outputs we already looked at, but I just want to show you it's exactly the same. So you have all this cross functionality between your schematic and your circuit board, and you can effectively work almost in each environment from each other tool, except when it comes to specific items like moving components and doing routes. But system setup, rule setup, output setup, everything is actually shared quite nicely between the two tools. The tools in the PCB would be more printed circuit board focused, as you'd expect. Moving and aligning components, checking distances, measuring distances between items is available. Auto route, we do have an auto route functionality in the tool. Once you get that set up, you can automatically pin escape your surface mount components. You can select particular types of routing. You could do a memory pass first. You could do XY focused pass second. You could do a final pass and then a cleanup pass. We have re-annotation, so full pin numbering, swapping I mentioned, but also full renumbering capabilities. You can customize the renumbering to your liking, top to bottom, right to left, front first, back first. It's completely customizable. So if we look at that, here's what we have the availability. We can do all these different configurations to re-annotate the PCB and then have that automatically update the schematic through the ECO process. So you do create an ECO, you read that change order into your schematic document, and you will get the updated reference designators from the PCB. Let's take a look at all of our available outputs, all industry standard. I'm currently running version 2017 Service Pack 1. The latest service pack that is now available is SP2, and another standard output has been added, and that's IPC 2581. So some of our manufacturers are moving to that format. SOLIDWORKS PCB can now provide that format file. We've also added image import capability within the PCB tool, similar to the Hawk Ridge image that I had on my schematic. Now we can bring in that logo into our PCB. So SOLIDWORKS is making already many, many enhancements after only having the product for less than a year. There's a question. Let me get to that. I was under the impression that it was incorporated into SOLIDWORKS in a flawless simulation. No, this is a standalone application. I'm going to now begin to move to the collaboration, and that's sort of the, it's not necessarily embedded, but we will be looking at this data inside of SOLIDWORKS, and we will be able to modify that, and we'll be able to bring that back into SOLIDWORKS PCB. But on itself, no, this is a standalone application, not incorporated within SOLIDWORKS, like for instance CircuitWorks or some of the other add-in tools that you have in SOLIDWORKS. This is a completely standalone application. Sorry I didn't get that question earlier. We will have time at the end for questions, but certainly if you have them, I can try to answer them right now. So let's move to, I'm going to finish up my outputs here. Okay, so I mentioned during the presentation a step file output, Parasolid, and VRML. Again, those will be models though. They won't be the real-time collaboration data that we're going to look at first. Gerber, of course, is standard. ODB is more intelligent. You need your NC drill files for drilling. We can do a design rule check, and we can also give all of our board information if we're doing an RFQ or something along those lines. All right, so let's take a look at what now we can do with a circuit board in collaboration with SOLIDWORKS. So inside the view panel, we have a SOLIDWORKS PCB connector icon. This is the panel that connects to our database. This is a database that runs on Microsoft Internet Information Software. So you place this database on a server where SOLIDWORKS users can attach to it, and Altium Designer users or SOLIDWORKS PCB users can also access that database. The big advantage for this tool, SOLIDWORKS users already have the capability to collaborate. It's built into SOLIDWORKS. It's been built into SOLIDWORKS since version 2016 Service Pack 3. All you have to do is turn on the add-in, and you have to log into the database. The advantage there, many companies, especially mechanical intensive companies, you may have 8 to 10 mechanical engineers, but maybe only 1 or 2 circuit board designers. All of those mechanical engineers could collaborate with the PCB designers. You do not need 10 licenses of the tool in order to make that happen. So once we're in the connector panel, we do a push of the data, and the data that gets pushed is the PCB itself. So that'll create a board part. And all of the models that are associated with the footprints. So the model definition in Altium Designer and SOLIDWORKS PCB is absolutely driven from the component library. Other 3D models that you may have in your PCB design, currently today those will not collaborate through the collaboration. You can certainly bring the models into SOLIDWORKS just like I can bring external models into the PCB tool. But it's the models that are associated with the components is what gets collaborated through the database. So let's just push our data out there to our database. Done. So now we've got this whole design file sitting out on the database, and we're going to go into SOLIDWORKS, and we're going to open up that same connector panel, and I would simply just pull it in. I've already done that for use of saving time, and I want to make sure that we can get through this a little bit quicker. But I am going to make the edits in SOLIDWORKS, and then I will push that data, and you'll see that update automatically happen. Okay, so I've already pulled that data in from the collaborative database. SOLIDWORKS creates an assembly. It's part of the protocol. It's the functionality of the tool. And then within that assembly, I mentioned that we get a single board part that contains all of the hole information for the through-hole components. So when we collaborate the PCB, SOLIDWORKS sort of separates now the models from the PCB, but those models that contained through-holes, drills in the PCB, those drills now become part of the PCB part. And that makes sense from a mechanical perspective, also from an electronic perspective, because I want to move the models in SOLIDWORKS. I'm actually moving the components, but the footprints won't update until we go back to SOLIDWORKS PCB or Altium. The only thing we will do in SOLIDWORKS is we can modify the location of the models. We can modify the locations of mounting holes. I can modify board outline information, and all of that will be automatically updated to the PCB in real time. So that's what we're going to do today. Is I'm going to grab a couple components. I'm going to make a modification to the board edge, and I'm going to move some of the mounting holes. So let's take a look at moving the board edge first. We just go to the board part and make an edit. Now I can drag it, I can dimension it, I can reference it against anything else. We're saving the future 3D solution spotlights to more elaborate how does the PCB look inside of a more complicated model. Right now we've only collaborated the PCB by itself, which is fine. A lot of customers would like the ability to define mechanical definitions within SOLIDWORKS regardless whether or not the mechanical components are there, and I can add the mechanical components later. So I'm just acting right now as I'm just going to assume that the board is not big enough. So we're going to slide this out a little bit, and we'll just leave it at that. Along with that, I have unfixed these 3 2-pin connectors. It is an advantage for the original component placement when it comes in. The components are fixed. That's so that you don't inadvertently grab them and move them around. So if you intentionally want to move a component, you will have to float it inside of SOLIDWORKS. So I've done that. I'm just going to grab these parts one at a time and just move them over to some new location. Again, I can dimension it, I can reference it. Let's say I have an electrical harness built for this, and the split out for this particular 2-wire set was designed by a different electrical engineer, and he's got the wires up here. No problem. I just move my connector up there, and we can easy match the harness. So we're going to drop these connectors further apart, or I could define the connector placement in SOLIDWORKS first that better matches my harness, and then I can let the PCB designer complete the circuit board based on my connector definition, not his or hers. So you see that I mentioned the through holes were broken apart from the model itself, and they remain in the circuit board. We will have to do one more collaborative cycle in order for the holes to be matched up to the new location of the model. But we'll see the movement of the holes inside SOLIDWORKS PCB when I do the collaborative update on that. Okay, so I've grabbed this hole, and now I'm going to move it down to a different location. I could also change the diameter of the hole in SOLIDWORKS, and it'll automatically update the drill size in Altium or SOLIDWORKS PCB. I could reference the hole against the standoff. I could reference it against whatever I like. Since we're in the mechanical environment, it gives us that kind of capability to make those kinds of mechanical edits. There's no other tool in the industry today provides real-time editing, okay? So we've made 3 edits, pretty simple. Let's just save our assembly and demonstrate what happens back inside SOLIDWORKS PCB when we push the data. Okay, so we're ready to make sure that we're refresh our database, look at the view. We got changes. Another real nice feature of this tool is I'm the circuit board designer. My mechanical engineer sends me some changes. I'm like, what has he really done to my design? So I can take a look at it by each individual item. See, there's the board showing that it grew. Here's the movement of J1. Of course, now it show off the board, but I do the board outline first and it'll capture it. I can look at everything at once. Everything's moving. The holes, the mounting holes, my connectors. If that looks good, then I can just say, check everything. And with a matter of 3 clicks, 2 minutes, 30 seconds, I have captured every activity accurately, 100% defined in SOLIDWORKS, now affects my printed circuit board. Of course, the electronic connectivity's not been broken. I now see a new guide wire from the end of the trace to the location of the new pin. So you can see we moved the model in SOLIDWORKS. The footprint gets updated. Now we would just push this data back out to SOLIDWORKS one more time to capture the new hole location in the PCB part. And that's essentially the full cycle for collaboration between PCB. One thing to remember, there is sort of this pass the ball back and forth because the last data that's on the database is going to be the master data as far as component placement and board part information. If I was in here doing routing, that's not going to get disrupted. But if I was moving components that were not moved on the SOLIDWORKS side, and the SOLIDWORKS mechanical engineer pushed a board file out to the database, my component placement that I may have done inside of the design while working in parallel would be lost, because the data from the database is going to be the most recent master database for component placement and for board part information. Okay, I'd like to go ahead and open it up for to questions and see if we have any questions or concerns, or what do we like, what do we don't like. Amazing, fantastic, impressive, all in an MCAD program called SOLIDWORKS. That is true. That's why we're focusing on that ecosystem, right? We want the ecosystem to be ready and allow customers full product development for one source of software, one environment, one value-added reseller. Any other questions? Well, I hope everyone can join for the next 2 SOLIDWORKS Electrical 3D Solutions Spotlight. Charles and I will continue and build upon this data set, showing many more functionalities of integration, collaboration, synchronization, ability for customers to really and properly design products with a one-stop shop solution. Yes, it is the question is, it looks like it's a good tool and it's only going to get better. Yes, and here's why it's going to get better. It's now a SOLIDWORKS owned tool, and it's a proven technology. This is not brand new technology. This is Altium technology. Altium's been around for 25 years. They have the most momentum in the PC board layout software environment. So by partnering with them, we can now begin to add functionality that's important to SOLIDWORKS users, to multi-product SOLIDWORKS users. Some of you are probably already thinking, okay, when can I get this in PDM? Great question. That is on the roadmap. No timeline, no definitions, no features. We're not discussing any of that today. But I just want to let you know that because it's SOLIDWORKS products, because they manage all of these other products, they are not going to allow this to just sit idle. We also maintain the connector for Altium, so there will be improvements in performance, improvements in hopefully maybe some other functionality in the connector, bringing over some additional information. Really, we'll have to see. There's a lot of things in the pipeline right now with SOLIDWORKS. They have a very large dedicated PCB design team. I've met everyone on the team, and we're in communication constantly. So it's very exciting. We've already made tremendous stride just in the year of 2017 release. The product now is available to go onto your solid network license. That was an enhancement in 2017. All of the PCB files are now also included in the SOLIDWORKS 2017 Installation Manager. That's another big advantage for customers. One download, I can install all of my products from one installation manager. Would anybody like to ask any other questions? If not, I guess we can go ahead and wrap it up, and I'd like to thank everybody again for joining.